Good morning to all. Is it clear my voice? Voice and picture. Now I am going to start the class. That is today we are going to start the new chapter, that is wave optics. This is our chapter. Okay, now I am going to start the wave optics chapter and you listen that is today we are going to start and you listen very carefully, and this chapter is very important, and from this chapter in the board exam you will get 5 marks, either long answer question you will get, or otherwise 2 marks or 3 marks question you will get. Okay, and listen very carefully. Now I am going to start. If you have any problem, and you can write in chat box, I will see that and I will respond immediately while teaching only, and you listen very carefully. If you have any problem while teaching, you can text in chat box. Okay, going to start the class. Right. The chapter name is wave optics. Chapter name is wave optics. This is my chapter that I am going to explain, and that is wave optics. This is our chapter name, and a very important chapter and a very interesting chapter. Okay, and listen very carefully. This chapter, previously we discussed about the ray optics. In that we consider that the light travel in the straight line path, and in that chapter we discussed about the properties of light, and that is the laws of reflection, refraction. Okay, and the lenses, optical instruments. About that we discussed in the ray optics chapter. Now in the wave optics chapter, and some more properties of light we are going to discuss. In this, we are going to discuss about the uh, interference, diffraction, polarization. These are three main parts in the wave optics. Okay, in this only three main parts are there. One is interference, next diffraction, next polarization. These are the three topics. Okay, and now first I am going to explain introduction to the wave optics. Then for that purpose, first what we have to learn in the wave optics. First of all, you have to we have to discuss about the wave front and the wave, how the light travel in the form of wave. We know previously, the firstly the Newton, according to the Newton, light travel in the form of particles, and the next Huygens gave that light travel in the form of wave or the wave fronts. Now, what is a wave or the wave front, and how light travel in the form of wave fronts, that I am going to explain. For the purpose, first we know that light travel light travel from one place to another place. Light travel in the form of wave or the wave fronts. Okay, light travel in the form of in the form of wave. Okay, light travel from one place to another place, that is in the form of wave, or the wave fronts. This is the final conclusion. Okay, now how light travel in the form of wave fronts, and what is a wave front? Okay, that we are going to discuss. First of all, what is a wave front? We know already about the wave. Then I am going to explain the wave front. What is a wave front? Wave front means it is the locus of all points which are in the same phase. It is the wavefront is the locus of all points. Locus of all points which are in the same phase is called as wavefront. Wavefront means it is the locus of all points which are in the same phase. What is this locus of all points which are in the same phase? That I will explain. Okay, we know in the mathematics locus. Okay, and here in the starting, what we are telling that the light travel in the form of wave or the wavefront we are telling. Then light travel in the form of wavefronts. Then what is a wavefront? Locus of all points which are in the same phase, which are in the same phase is missing here, which are in the same phase. This is important word, which are in the same phase is called as wavefront. Depending upon the source of, depending upon shape of source, depending upon shape of source of light. Wavefronts are three types. Now the wavefronts are classified into three types. Wavefronts are three types. What are they? The first one is the spherical wavefront. Spherical wavefront. And the second one is the cylindrical wavefront. Cylindrical wavefront. Okay. Font size I have to increase, right? Okay. Third one is the what? Third type of that one is it appearing now clearly? Twinkle. I increased the in the zoom I gave that you see a little bit the size is increased. The third type of wavefront is the plane wavefront. Plane wavefront. These are the three types of wavefronts, and actually I will explain. Or you may have confusion what is wavefront and how three types of wavefronts are there. The first one is the spherical wavefront. What is a spherical wavefront? And which source can emit the spherical wavefront? Before that, I will explain actually what is wavefront. You may have little bit confusion regarding the wavefront. The light travel in the form of wavefronts. For example, this is the source of the light. It is the source of the light. The light is traveling in all directions like this. Light travel in all directions like this. When the light traveling like this, and light travel in the form of wave, this is a wave like this. This is the wave, right? And for example, when it goes this side, its angle will be increases. For example, it is going like this. Then, for example, initial angle we can take as 0 at here. You take it as 0. And when it come to here, it is going down. Then here angle become 180. 180 we can say that pi. Here angle it will become upward direction. Okay, here upward become downward pi. Next downward become upward vibration 2 pi, 3 pi, okay, 4 pi. Like this angle will be increases when you will go to right side. Why? Because firstly it is upward vibrating, next downward, next upward, next downward. Its a phase angle will be changes. Phase means it is nothing but angle. Phase means angle. Okay, phase increases while traveling, right? When the light travels in the form of wave, its phase will be increases. Okay, its angle will be increases. For a, this for here it is 0, then here it is 180, and here it is 360, like this. Here it is 3 pi. Pi means 180. Pi is equal to pi radians is equal to 180 degree. Right? Here 0 degree, here 180 degree, and here 360 degree. 360 we can write as 2 pi. Like this angle will be increases. And this angle is called as the phase. For example, after traveling some distance, okay, and then it has some angle, that angle is called as a phase. This phase is, for example, here 5. These are the some points. For example, these are the some points which are at the same distance from the source, and these all points having the same, for example, a, b, c are the three points which are at the same distance from the source. Okay, which are same distance from the source. S is the source at here. Then these three points are at the same distance means they have the same angle, and these phase angle is also same, 5 5 5. 5 is the phase angle at here. Then the locus of all these points, you join all these points which are having the same angle. Okay, you join all these points, then we are getting a shape like this, and this shape is called as a wavefront. What is a wavefront? Wavefront is the locus of all points which are in the same phase. Locus means what? Locus means you have to join all the points which are in the same phase. Okay, locus means you have to join all the points. Okay, which points I have to join? We have to join all the points which are in the same phase. Same phase means same angle. Okay, and when the light ray travels, its phase will be changes. And now the locus of all points which are in the same phase are called is called as the wavefront. Okay, you see here. And now spherical wavefront. Which type of source can generate the spherical wavefront? The spherical wavefront is generated by the point source. Okay, it is produced by it is produced by point source. It is produced by point source. Okay, if point source is there, then it can produces the spherical wavefront. Okay, what is the source of the spherical wavefront? Who will produce the spherical wavefront? The point source can produce the spherical wavefront. Let us see here. This is a point source. Point source. Okay, this is a point source. Then this point source emitting light rays in all the directions. For example, we take some light rays at here. This is the one light ray, it is going this side, and this is another light ray, it is going this side, and this is another light ray, it is going that side, and this is another light ray. Like this light rays will be travel in all the directions. Now for example, you take some points at here, and let us consider this is a point, okay, a, and this is a point b, and this is a point c. Okay, and you take some points at here, and then these points are at the same distance from the source s. This is the source s. From the source s, they are at the same distance. S is the source. And now if these points are at the same distance, then you join them, you will get a locus of the all points which are in the same phase. Phase means angle same. Angle should be same. When angle will be same? If the points are at the same distance from the source, then the angle will be same. Okay, then we have to join all the points which are in the same phase. You will get one circle. In the two dimension, it is a circle, but in three dimension, it will be a sphere. Okay, this is circle. This circle, for example, this is the point A. We have to take the point A here. Okay, this is the point A, and this is the point B. Okay, and this is the point C, and this is the point D. Here, A, B, C, D are at the same distance from the center, from the source, and if these are at the same distance, okay, then they have the same phase. The locus of all these points which are in the same phase, that is called as wavefront, and the wavefront, this wavefront is the spherical wavefront, right? And now it is the spherical wavefront. This is called as spherical wavefront. That means the wavefront is in spherical shape. That means just like a sphere. You assume, I will explain for this. You assume one point source, okay, one point source. And here, from the point source, how the light will be traveling? Light travel in all the directions. Okay, and you take one sphere like this. Okay, first light come up to here. Then after that, you take sphere with a large radius. Light comes up to here, and you take the sphere with large radius again. Light comes up to here. Like this, light will be traveling in all the directions in the form of the spherical wavefronts. Then according to this, Huygens explained this one, that is the light travel in the form of wavefronts, and these are called as wavefront. And the inner circle you see here, this is the first wavefront, right? And this is the second wavefront, and this is the third wavefront. Like this, light will be travel in the form of wavefronts. Light will travel in the form of wavefronts, and the point source can be produced generated. Point source can generate the spherical wavefront. The important point is that who is the source of spherical wavefront? What is the source of spherical wavefront? What is the source of spherical wavefront? Okay, point source of S is what here? Point source of point source of light. It can produce the spherical wavefronts. Okay, light travel in the form of spherical wavefront. Just you assume that one point source is there, and from that the light will be traveling all the directions. All the directions means just like sphere. Just you take one uh, ball. Okay, you take a sphere ball you take, and at the center you assume one source of light is there. If the ball is around it, okay, ball ball is a sphere, at the sphere center source is there. Now the size is increasing it here. If the ball size is increases in all the directions, then one ball is the wavefront, and the ball size is increasing means then the new wavefront will be increasing, producing, and the light will be travel in all the directions. Light will travel in all the directions in the form of wavefronts. Okay, this is about spherical wavefront. Who will generate the spherical wavefront? The point source can generate the spherical wavefront. And the next one, second type of wavefront is what? Second type of wavefront is second type of wavefront is what? That is the cylindrical wavefront. Cylindrical wavefront. Light travel in the form of wavefronts according to the Huygens. Then who will generate the cylindrical wavefront? What is the source of cylindrical wavefront? That is, a cylindrical wavefront is generated by the linear source. Okay, it is produced by it produced by linear source. It produced by linear source. Linear source can produce this cylindrical wavefront. Example for this is a slit. Slit can generate the cylindrical wavefront. How the cylindrical wavefront will be there? For example, you assume a tube light. Tube light is the linear source. Tube light is the linear source. For example, this is the source. It is the source. This is the source. This red line is the source. And now around this line, light will be travel in all the directions. Then you assume one cylinder like this. And this is called as wavefront, cylindrical wavefront. Because the wavefront is in the shape of cylinder. Okay, and now light will be travel in all the directions here. This is the source. Then the light ray, if you will go like this, light ray will travel in all the directions. Okay, and now next one is the plane wavefront. What is plane wavefront and what is the source for the plane wavefront? Plane wavefront is that it is a small pot of spherical or cylindrical wavefront. A small part of a a small part of a spherical or cylindrical wavefront. A small part of spherical or cylindrical wavefront originating from, that means that wavefront is starting from, originating from a distant objects, from a distant source, will appear as a plane wavefront. This is a plane wavefront. You see here, I will explain whatever that I wrote it here, and you listen very carefully. And how the plane wavefront will be there. For example, the source is at long distance. Source is at long distance. For example, this is the source, and it can emit the, this can emit the source. If it is point size, then it can emit the spherical wavefront like this. Okay, this is a spherical wavefront. This is spherical wavefront can generate the another wavefront. Another wavefront again it will generate. Like this, the spherical wavefront around the source will be generated. On the left side I am not drawing because it will enter into the other region. Only I am right side I am drawing. This is the first sphere, this is the second sphere, this is the third sphere, this is the fourth sphere. These all spheres are the wavefronts. And if you take the light ray will be travel like this. Okay, light ray travel in the straight line path. Like this, light ray will be travel. And when the light travel to long distance like this, then the small part of a sphere, this is also goes to, it will become circle like this. But if you take the small part on the wavefront, this small part appears like plane, and this is called as plane wavefront. Small part on the sphere. When it appears like a, plane wavefront, when it appears like a plane, for the, if it is, if the source is at long distance, if you take the large sphere, our earth is a large sphere, but we are staying at some place. On that place it will not appears like sphere, it will appears like a plane. Is it right? We are staying on the earth, but the earth is a large sphere. Then the large sphere, if you take the small portion on the large sphere, that cannot appears like curve, it can appears like a plane, right? It can appears like a plane. Then here also same thing. When the source is at long distance, then one wavefront can, first wavefront can generate the second wavefront can generate the third wavefront can generate the fourth wavefront, like this fourth can generate the fifth, Like this, what happens, the wavefronts can be light travel in the form of wavefronts in all the directions. And then wavefront is means what? Wavefront is the locus of all points which are in the same phase. And now small portion, small portion on this eighth wavefront, you see it appears like a straight line, but that is in 2D it is a straight line, in 3D it will appears like a plane. And the small portion on the earth also appears like a plane, and that portion is called as the plane wavefront. Okay, plane wavefront. Plane wavefront in 2D we write just like a straight line, but actually it will be a plane. Now let us see, and that is the plane wavefront. And the plane wavefront means what? A small part of spherical or cylindrical wavefront. That cylindrical or spherical wavefront, okay, generated from a source. That source should be at the long distance. Okay, then for example, from the sun, the light is coming. Then the light travel in the form of spherical wavefronts, and then after traveling to this much distance, then light appears like a plane wavefront. Okay, and then light travel like this. Let us consider this is the direction of the light. Light rays, light rays are traveling like this, and the plane wavefront, how it will be there? If you draw the plane wavefront, then it will be appears like this. Okay, these are the four light rays. You join the four light rays, okay, and this will is called as plane wavefront. Plane wavefront, okay. And what is this? These are the light rays. For the exam, what you required from these topics? Okay, just you required one. Okay, and you should remember what is wavefront. First, locus of all points which are in the same phase. Phase same phase means this is a source. You take some points which are at the same distance from the source, some x distance, some x distance, some x distance. Then these points having the same phase, and you join these points. Okay, you see here A, B, C, D, join them. They are at the same distance from the source. The locus of, if they are at the same distance from the source, they have the same angle. Phase angle same means phase is same. Then that all points you join, you will get a shape, and this shape is called as a wavefront. Again, I explained what is wavefront. And the wavefront has the different shapes, that is depends upon the source. And if the source is point, then the wavefront is spherical. Okay, if the point source is there, then the wavefront is spherical. If the source is linear, linear like length, then cylindrical wavefront will be generated. If the small part on the spherical wavefront is called as the plane wavefront. Okay, and then next one point in the note I will give. Okay, that is the, if the light rays are going parallelly, light rays are traveling parallelly, then how the wavefront will be there? If the light rays are moving parallelly, then the wavefronts will be like this there. This is a wavefront. It should be straight line. Okay, this is called as a wavefront. And how it is? It is a plane wavefront, right? It is a plane wavefront. And if the light rays are converging, then what happen? What type of wavefront will be generated? Or if the light rays are diverging, okay, these are the parallel beam of light. First one, A is the parallel beam of light, parallel light rays. The second one is the diverging. This is a source. From that, light rays are diverging. Like this, light rays are going like this. Okay, light rays are going like this. For this, how the wavefront will be there? For this, how the wavefront will be there? Wavefront will be just like a spherical. You join all the points which are in the same phase. And this is called as a spherical wavefront, the black one. Okay, spherical wavefront. Okay, spherical wavefront. And if the light rays are converging, this is the B diagram. Okay, B diagram indicate diverging. This one is diverging. Diverging means light rays are going away from each other. Diverging light rays. Next is C case we will discuss. Okay, C is that converging light rays. Converging light rays. Converging. Converging light rays. Converging light rays means this is a source. Okay, now it is not source. If you keep the convex lens, it will converge all the light rays, right? Okay, and the light rays are converging like this. Light rays, all the light rays are meeting at one point. In this case, how the wavefronts will be there. The wavefronts will be like this there. This is the wavefront. This is a wavefront. This is a wavefront. Okay, right. And this is the wavefront. Wavefronts will be like this there. Okay, and now what is the angle between the light rays and the wavefront? You see here the wavefront light rays are always perpendicular to the, you see this diagram, above diagram, and this is a light ray straight line and it is always perpendicular to the plane, right? And now light rays are always perpendicular to the wavefront. This is for example in the note first point, and in the note second point I am going to give, and you uh, take the screenshot and note it. I'm going to erase. Right. In the note, second point is that light rays always perpendicular to the 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 wavefront. Okay, this is the second point in the note. Next, I am going to explain the important point. And till now, we discussed, I think, 30 minutes. But in that 30 minutes, what we learned? Only a few points that are important for the exam. And that are the first point is that what is wavefront? Light travel in the form of wavefront. And what is a wavefront? How many types of wavefronts are there? Second one is completed. There are three types of wavefronts are there: spherical, cylindrical, and one more is plane wavefront. And in exam, they may ask only that what are the sources of the wavefronts? Who will generate the spherical wavefront? Who will generate the plane wavefront? And who will generate the cylindrical wavefront? That they will ask. This is the point. And the next, just drawing the wavefronts. Then next, Huygens. I am going to explain the one more important topic, that is the Huygens principle. Okay, and this is important for the 3 marks. You listen very carefully, right? And the writing, voice and writing. Is it clear? Anyone can respond? Huygens principle. Huygens principle. This is very important for the 3 marks. Okay, for the board exam. What Huygens principle? Huygens is the name of the scientist. What he gave, he explained how light travel in the form of wavefronts. Actually, the light travel in the form of wavefronts, and that is explained by the Huygens only. Light travel in the form of wave and wavefronts. How light travel in the form of wave or wavefronts? Okay, that I am going to explain, and that is explained by the Huygens. Right? What Huygens said and how he explained the light travel in the form of wavefronts. Let us see. He gave few points regarding this. That few points are the first point is that it was very simple. First I will explain and later I will give the points. Okay, first I will explain. And this is the source of the light. Okay, you see here, this is the source of light. And now light travel in all the directions from the source. You know this one very well, right? Light travel this side and light travel this side. Light travel in all the directions, right? That you know already. Light travel in all the directions. And then if the light traveling like this in the form of wave it is traveling, then its angle phase will be increases while moving. If you join some points which are in the same phase, means which are at the same distance, these are some, this is the one point, this is the one point, this is the one point, okay, this is the one point, this is one point, like this. You join some points, okay, like this, and they are at the same distance from the source. When you join them, the locus of all these points is called as the wavefront. This is the wavefront. It is the wavefront. It is in just like if you join, if the source is point source, if you join all the points, then you are getting like a sphere. Actually in the 2D chapters like circle, in 2D chapters like circle, but in the 3D it is a sphere. Okay, and now Huygens, how he explained it. This is a wavefront now. Okay, the wavefront in the beginning it is generated. It is called as the primary wavefront according to the Huygens. This is the primary wavefront. Primary wavefront. Okay, and the next this primary wavefront. Every point on the primary wavefront. You take some points on the primary wavefront. Every point on the primary wavefront will act like a new disturbance. Every point on the primary wavefront act as a new disturbance. It is act as a source again. Actually actual source is yes, but on the wavefront every point also act as a source, and it can produce the new disturbance and it can produce the new wavefront. When it can produce the new wavefront, it will produce like this blue color one, new wavefronts. Okay, this is the new it is acting like a source. It can also generate the wavefront, then that is the new wavefront. And you join these new wavefronts are called as the wavelets, right? And you join all the wavelets again. You join all the wavelets, then the locus of all the wavelets produce the one more wavefront. This is called as the secondary wavefront. Secondary wavefront. Then again on the every point on the secondary wavefront act like a source, and it can produce the new disturbance. Again it can generate the wavelets, new wavefronts, and then the locus of all these, this is the wavelets, and the locus of these wavelets again it can produce the one more wavefront. Like this light can travel in all the directions in the form of wavefronts. Firstly one wavefront is generating, this is the one, and the next second wavefront is generating, next third wavefront is generating, next fourth wavefront will generate, and next fifth wavefront will be generated. Like this light travel in the form of wavefronts from the source to all the directions. This is about Huygens principle, and this is how Huygens explained the wavefront theory, and how light rays travel in the form of how light travel in the form of wavefronts. Okay, and this is the thing, and what he explained very simple. This explain Huygens principle. This is important for the exam. Okay, and he explained the few points. Okay, that is very easy. And first I will draw the diagram clearly. Then after that I can give the few points again. Okay, and you see here. I will draw the clear diagram now. And this is the source S. It is the source S. Okay, and from the source light travel in all the directions, but I am taking only one direction like this. Okay, these are the light rays from the source. Light travel in all the directions. Light travel in the straight line. You draw the straight line, but here sometimes I may not get the straight line because of this pen problem. You must draw the straight lines. It was very difficult to draw the straight line by using this pen tab. And now, okay, even though I will draw like this, so here, see here. Okay, next time directly I will draw whatever it may be. This is the source. It is emitting the light rays like this, and the light rays will be traveling in the straight line path. And you take some points, okay, and join all the points, and that is called as a wavefront, okay. And this is the wavefront, and this is the primary wavefront. Okay, you see here, this is the primary wavefront. This is called as the primary wavefront. Primary wavefront. What is primary wavefront? The locus of all points. The locus of all points which are in the same phase. It is called as the primary wavefront. And now on the primary wavefront, every point will act as the source of new disturbance, and it can produce the wavelets. It can again produce the wavefronts. Then you join all that small wavefronts. These are the wavelets. These are called as the wavelets. Okay, and the join all the wavelets now. Okay, join all the wavelets. It can produce the one more wavefront, and this is called as the secondary wavefront. Secondary wavefront. Secondary wavefront. And now again, every point on the secondary wavefront will act as a source of the new disturbance, right? Like this, and it can also produce the wavelets, small wavefronts. You join all them, you will get the one more wavelets. Like this, light travel in the form of wavefronts. Okay, right. This is the second one, and this is the third one next. Like this, light travel in the form of wavefronts in all the directions. Then what he gave the points first. First point is that very simple and very important. Each point each point on the given primary wavefront, each point on the given primary wavefront acts as a source of acts as a source of new disturbance, source of new disturbance. Okay, each point on the given primary wavefront. Here, this is the primary wavefront. You see here, first wavefront is the primary wavefront. First blue line is a primary wavefront, and every point on the primary wavefront. Okay, we are taking some points at here. You see, and every point on the primary wavefront, not only these points, every point on the wavefront act as a source of new disturbance. That means it acts like a source, and it can also produce the wavefronts, small wavefronts, and that are called as the wavelets, right? You can produce the new. Each point on the primary wavefront act as a source of new disturbance. New disturbance. It act like source of the new disturbance. These new disturbances, okay, is called as the wavelets. The new disturbance from each point spread out. Second point I am going to give. The new disturbance. The new disturbance from each point. New disturbance from each point spread out in all directions. Spread out in all directions are called as wavelets. Are called as wavelets. Look at here, that is a new disturbance. It is act like a new disturbance. That new disturbance, what we are telling it here. Firstly, you see the blue line is the primary wavefront. Every point on the primary wavefront act like a source of new disturbance. Means it act like a source and it can produce a new disturbance. Again, new light it can produce, new wavefront it can produce. That new disturbance from each point. Okay, from this point also new disturbance came here. Okay, new disturbance came. That new disturbance we took only right side, but it is also there in the left side also. This side also it will be there, but we not run only one direction we took. And now that new disturbance from each point, every point act like a source and of new disturbance. It can produce the new wavefront. It is a source of light, and that new disturbance can spread in all the directions like wavelets. These are called as the wavelets. This. And now third point. Okay, you join all these wavelets, you will get the one more wavefront. That's all. The envelope of the envelope of secondary wavelets. The envelope of secondary wavelets. The envelope of secondary wavelets is called as is called as secondary wavefront. Secondary wavefront is called as a secondary wavefront. Now you see here, this is the envelope of these all lines. Okay, this is the small wavelet. It is a wavelet. It is a wavelet. The envelope, you join all the wavelets like this. You will get one more blue line. That blue line is called as secondary wavelets. Like this, one first primary wavelet can generate the wavefront, can generate the secondary wavefront. Secondary wavefront can generate the third wavefront. Third wavefront can generate the fourth wavefront. Fourth wavefront can generate the fifth wavefront. Like this, light will be traveling in the form of wavefronts, and this is explained by the Huygens, and it is important for the 2 marks. Explain Huygens principle. In this way, in this way, light travel, light travel in the form of wavefronts. In the form of wavefronts. Every wavefront can generate the new wavefront. In this way, light travel in the form of wavefronts. This is according to Huygens, right? And now this is the important point. The next we are going to I'm going to explain one more two topics that are also very important. Okay, you listen very carefully. I'm going to erase this. You take the screenshot and note every point. Now I'm going to explain some important topic, and you listen very carefully, right? More 15 minutes I will continue, and you listen very carefully. Very very important for the exam, whatever that I am going to explain now, and that is very important for the exam. Every topic is very important because from this chapter you will get the 5 marks. It's a small chapter. It not have more topics like ray optics. In the ray optics you studied the so many topics. and last 17 days we are discussing the ray optics chapter only. Now I'm going to start. Listen very carefully, right? Right, let us start. And first topic is that verification of, very important topic, refraction of the plane wavefront. This is our topic. Refraction of plane wavefront. How wavefront will goes refraction? We know previously that is light travel in the form of straight lines, just like light rays. How light ray undergoes refraction we know, but now we are telling that light travel in the form of wavefronts. Then wavefronts also undergoes refraction, and wavefronts also undergoes reflection. Wavefronts also obeys the laws of reflection, laws of refraction, and that we are going to discuss. There is a refraction of plane wavefront. How plane wavefront will undergoes refraction. Refraction of plane wavefront. And light ray, how it will goes undergoes refraction we know, right? And plane wavefront, how it will undergoes the refraction, that I am going to explain. And that is verify this question. They, based on this, they may ask the question, 3 marks question, very important for the 3 marks, very important. Many times it came in the board exam. And that is verification question. They will ask like this: verify laws of refraction based on Huygens principle. We have to verify the laws of refraction based on Huygens principle. Question is that verify laws of refraction based on Huygens principle. This is the question. Based on Huygens principle, we have to verify the laws of refraction. You know about the laws of refraction. What are the laws of refraction, right? Let us start to verify them. For that, what we have to do here, we have to, we are going to verify the laws of refraction. For that, we have to take, this is a boundary which separates the two medias. Okay, it is a boundary. For example, this is the medium one. Okay, medium one it is. This is the medium two. The light ray is trying to move from one medium to another medium. At that moment, the light ray will bend. That is called as the refraction. Very important topic. Okay, you must listen carefully. This is the medium one and this is the medium two. Here, the above this boundary medium one is there. Below this medium two is the light is traveling from one medium to another medium. At the moment, the light will be bent. That is called as the refraction. But here, we are going to explain. I am going to explain the refraction of plane wavefront. For that, I will take the two light rays first. For example, the source is at infinite distance. Source is at infinite distance means light rays comes parallelly. I will take the two light rays. Okay, you see here, one light ray is instanting like this. This is one light ray, first light ray, and next this is the second light ray. These are parallelly instanting it here. Two light rays are instanting it here. Then how the wavefront will be there? You remember that the wavefront is always perpendicular to the light ray. Perpendicular means, for example, the wavefront will be like this there. This is the wavefront. Wavefronts are instanting like this. This is the wavefront. This is the wavefront. Okay, when the wavefront is moving forward like this. Okay, like this. The wavefront is going. And now the wavefront is incidenting on the boundary now. Light rays are incidenting, the wavefront is incidenting. When the first light ray, okay, both are starting from here, and first light ray reaches the boundary and incident on the boundary. You see the diagram, arrow mark you see. The first light ray incident on the boundary. Second light ray started from here and it comes up to this location. Okay, that means in the first light ray incident on the boundary, at the moment the second light ray is at here only. Okay, because this to reach the boundary, first light ray should travel less distance, but the second light ray should travel more distance. For that, more time takes. That means firstly the first light ray reaches the boundary. After few seconds, the second light ray reaches the boundary. In the medium one, the speed of light ray we can consider as okay. The light ray is in going like this. This is the wavefront. Okay, you see here. What is this? It is the incident wavefront. This is AB. AB is the incident wavefront. You see here. And now the light ray started at here and it is incident at here. Incident at here. And when light ray traveling and it is incidenting at A dash. You see here. This is A dash. And now it undergoes refraction. Light undergoes refraction. We have to draw the normal for that. This is the normal drawn. You see. Normal drawn. This is the normal. And this is the normal. Listen very carefully. This is very important. This is the normal. And this is called as the angle of incidence, right? This is the angle of incidence. And this is the angle of incidence. Okay. And what is AB in the figure? What is AB? Incident wavefront. The wavefront is incidenting on the boundary. Incident wavefront. Incident wavefront. Okay. Incident wavefront. And now wavefront is coming like this. You see here. This is the wavefront. You see the diagram, arrow mark. You see. This is the this dotted line is the wavefront. When light ray come to this location, this is the wavefront. Next, light come to here means this is the wavefront. When light comes to here means this is the wavefront. Then the light incidenting on the boundary. This is the wavefront. You see here that the red line AB is the wavefront, always perpendicular to the light ray. Okay, and now it will undergoes refraction. For example, the medium 1, in the medium 1, the speed of light we can consider as the V1. In the medium 2, the speed of light we can consider as the V2. Okay. And now, when the light ray moving from one medium to another medium, it will bend. It cannot go in the straight. Actually, if there is no change in the medium, light travel in the straight like this. You see the diagram, arrow mark you see, cursor you see. Light should be traveling in the straight line. Okay, but if there is no change in the medium, light travel in the straight line, but here the medium is changing. That's why light never travel in straight line, because it is going from medium 1 to medium 2. If the light ray travel from rarer to denser, it will bend towards the normal. Towards the, it should not go straight like this. It will bend towards the normal. Normal means this is the normal, right? Then if it will bend, then how it will go? See here, it will go like this after the bending. This is the refractor light ray, and here also it will bends like this, and these are the refractor light rays. Okay, you see here. These are the refractor light rays. And then after that, wavefront we have to draw. Wavefront is again perpendicular to the wavefront is again perpendicular to the light ray, and you join this. This is A dash and B dash. And A dash B dash, it is perpendicular to the light ray. You see here 90 degree. 90 degree. Okay. Now A dash B dash is what? It is a refracted wavefront. Listen very carefully. Very important topic. It is a refracted wavefront. Okay? Right. Now, this is 90 degree. And this angle is what? What is this? This blue line in the second medium. In the second medium. And this is the normal drawn. You see the diagram and the cursor you see. And this angle is called as angle of refraction because it is a refracted light ray. It's a normal. and this angle is called as angle of refraction. Angle of refraction. And this angle is called as angle of refraction. Okay, right. You see, this is normal, and this is R. What about this angle? This is normal means this is the normal. This total angle is 90 degree with the boundary 90 degree it will be there. When this is R, you see this is R, then this will be 90 minus R, because the sum of these two angles. If you go for this one, what about this angle? I want this angle. This is 90 minus R. Why it is 90 minus R? Because the sum of these two angles R and 90 minus R should be 90, because this line dotted block line is a normal. It should be makes 90 degree. And here you see one triangle A dash B dash A. Okay. And this is 90, this is 90 minus R. Sum of three angles should be equal to 180 degree. That's why this angle should be R. This is 90 minus R, this is 90, this is 90 minus R, 90 R. Sum of three angles will be 180. Okay. And from the figure you will get this is angle I. Okay, this is angle I. This is angle I. And this total red line makes this red line AB. We know that AB is perpendicular to this light ray. AB perpendicular to light ray. And that means this angle is 90 total up to red line and blue line, wavefront and incident light ray. First incident light ray angle is 90 degree. You see the cursor, it is moving like this angle from where to where, blue line to red line. It is a plane, maybe is the plane wavefront and blue line is incident light ray. The angle is 90 degree, 90 degree. And this is I means what about this angle? Angle between the NAB angle will become 90 minus I, because the sum is 90. When this is 90 minus I, okay, you see here, this is 90 minus I. This will become 90 minus I. When this is 90 minus I, what about this angle? Again, this is perpendicular. You see the diagram. A dash. It's a 90 degree. This is 90 minus I means this should be I. This should be I, because sum of the angle should be equal to 90 degree here. Okay, like this you will get from the figure. And then what happening at here, when first light ray incident on A, the second light ray not incident on boundary, it is at B. Okay, when first light ray reaches the A, see the figure very carefully. First light ray incident on A, second light ray reaches up to B, second light ray reaches up to B, and then first light ray refracts and goes to up to B dash, then the second light ray travel B to A dash. For example, first light ray, second light ray traveling, second light ray is at B, first light ray is at A. Second light ray from B it is moving again forward, and first light ray refracts and goes forward. And then when second light ray travel from B to A dash in time t, okay, and the first light ray travel, first light ray undergoes refraction and travel from A to B dash. Because here you see first light ray incident on boundary, because it is at less distance, it travel less distance. But second light ray, when first light ray reaches the boundary A, point A, second light ray not reaches the boundary, it is at B. When second light ray again it is continuing to incident, continue to travel to incident on the boundary, then when second light ray travel from B to A dash, in that time the first light ray travel from A to B. Okay, the one important point I am going to give. When second light ray, when second light ray travel, when second light ray travel from B to A, Very carefully you have to listen. B to A dash. This is the second letter. Second letter A, when first letter is at A, second letter is at B. Second letter A moves from B to A dash. In that time, what happens? First letter A, where it is? First letter A, when actually first letter A, second letter A, both are moving. But like first letter come to the point A, the second letter come to the point B, and second letter again continuing B to A dash. At that moment, first letter again continue. That means continue means going to another medium. Going to another medium means it will bends, refracts, and enters into the medium 2, and it travel from A to B dash. When second letter travel from B to A dash, okay, in medium 1, in medium 1, in that time in that time, okay, when the first letter second letter travel from B to dash, in that time in that time in that time what happens? First letter A, first letter A, very carefully you have to listen. From the diagram only everything will come. First letter refracts and travel from from A to B dash in the medium 2. Once again, okay, you see here. When second letter, you see the diagram, arrow cursor is moving. When second letter moves from B to A dash, in that time the first letter refracts. When second letter is at B, first letter is at A. Second letter starts to moving and first letter starts to moving. And second letter goes from B to A dash and first letter moves from A to B dash. A to B dash. That only I am giving. When second letter moves from B to A dash,